Hey everyone, today we'll be going over graphs today, focusing on recursive breadth first search for an unweighted graph, and without any further hesitation, let's get started. And now we're going to perform breadth first search recursively. So the way we're going to do this is that we always know that recursion typically has two functions, two functions really, where we are going to have our helper function and then the function we call, just based on the principles of recursion. So void breadth first search. So this is going to be our helper function, recursive for q int and q. Then we're going to have a vector of booleans and indicated what has been visited. Let me just zoom out here. There we go. That's better. Now with that, we are going to say, hey, if the queue is empty as an edge case, then we are just going to simply return saying, hey, there's nothing in there. Then we're going to initialize each vertex at the queue's front. And then we're going to keep popping the queue to determine exactly, hey, this is a vertex that we have visited, and we're just going to output the following right here. And then we're going to scan through our adjacency list for auto I. It's going to be the adjacency vertex at the beginning. And then if the adjacency, if the index is not at the end of the adjacency list, then we're just going to keep incrementing our index until we reach the very end. And we are going to say, hey, if this index in the adjacency list has not been visited, then we are going to say visited I will be indicated as true because we're dealing with a boolean over here to indicate, like saying, hey, this has been visited. Make sure you spell everything correctly. There we go. And then we're just going to push the following iterator inside of our queue or index value, I would say. Hence the star I. And then what we are going to be doing is that we're just going to keep calling upon this function for visited right here, and that way it's just going in that loop, hence principles of recursion. Now the next part will be the other function that we will have, the function we will call. So void BFS recursive. At the very start, we'll have a vertex on the inside indicated as parameter v lowercase. Then we're going to have a vector of booleans indicated what has been visited. For the vertex we have initialized at the top, right here, going down, and then saying, hey, we have not visited anything yet, but we're going to, and then we're going to have our queue that we are going to make, call this queue. This is how we make this tool, and then we're going to have visited for each vertex indicated as true, since we were dealing with Boolean vector. So it's literally taking this, saying, hey, the following vertex in the following parameter that we have inside of our vector is going to be indicated as true, since each vertex is going to have a condition true or false for our vector, since we already have a pair of the integer value and indicating whether or not it's true or false. Then we're going to push each vertex inside of our queue, and then we are going to call upon our helper function on the inside that we have made. Let me get a view of that. Recursive, and then we're going to put in queue and then visited as well, hence the parameters of the queue that we have, and then the vector, the Boolean vector as well. And don't forget your semicolons, and then finally we're going to output at the end. Now let me just build this to make sure this is all good. Build succeeded. Well, we're not going to run anything yet because we need to go down, and all we have to do is that we're going to do the same thing that we did over here, except we're going to do recursion. Breadth first search recursive starting at the vertex 0, and that means BFS recursive start, because this is the function that we have that's going to call upon this function for principles of recursion and just keep everything tidy per se. People would actually have a bit of an argument saying recursion is easier to put in and implement, so that way one knows exactly what to be able to output. Now I'm gonna run this. And we get the same output that we have from our iterative. We just designed it differently with a different pattern of design called recursion. And let me just go up. And hence we already know exactly the format because breadth first search goes based on level. So we see a 0, 1, 5. Look at that, 0, 1, 5. And then we see 2 and 4, 2 and 4, and finally 3 is indicated over here. And that would be breadth first search, because breadth first search goes on levels and depth first search goes on depth for the graph. And so yes, this was breadth first search recursive overall. And now let's go over a brief overview for unweighted graph, knowing the exact definition of such and how it compares with our other graphs as well. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.